Hello everyone, how's it going? My name is Dan the Tutor, on a mission to become the world's greatest tutor. In today's video, we're going to be talking about how to find the equation for a piecewise function given the graph. So basically, I'm going to give you the graph of a piecewise function. And in case you're wondering, a piecewise function is just like any other function, except it kind of looks like I smushed two different functions next to each other like this. You may be thinking, hey, wait a minute, this is just an absolute value function. Well, you're kind of right, this does look like an absolute value function, but all absolute value functions are really just piecewise functions in disguise. And remember, piecewise functions are the functions that have the curly bracket with one thing on top and one thing on the bottom. So here's what I'm going to do for us. I'm going to give us some coordinate points. So this point right here is 2, 0. I'm going to give us the y-intercept, which is at 0, 2. And then I'll give us this point right here, which I will say is at 5, 2. And now I want you to give me the equation of the piecewise function that makes this up. And I'm going to be helping us with this first one. The first thing you need to do is you need to identify how many functions I have here. In this case, I just have 2. The first one is the downward sloping line on the left. The second one is the upward sloping line on the right. And as we can see, the function breaks up right here along the line x equals 2. So in other words, when I make my piecewise function, instantly I know two things. The first thing I know is my piecewise function is going to have two parts. The second thing I know is I already know the ranges for the domains. One range is x is greater than 2. The other one is x is less than 2. Now, as you can see, since there is a closed circle, a closed dot at the point 2, 0, it means that one of these needs the equal sign. And let me tell you, there is no right answer. It literally can be either one because they meet up at the same point. So I will choose the top one, greater than 2. If you wanted to choose the bottom one, that's fine as well. So now, I will say this, I messed up the order a little bit because x is greater than or equal to 2 is technically the right one. You can flip it, you can have less than 2 first up top, but whatever, it doesn't matter. So if I want to start with greater than or equal to 2, I need to find the equation of this line here, which I will color code blue for us. So first I notice this is a linear line, y equals mx plus b, and I know how to find the equation of linear lines, and if you don't, then you're in trouble, and you should watch another video on how to do that. But all you need to do is recognize this is x1 and y1, and this is x2 and y2, which means I can plug it in the slope formula, m equals y2 minus y1 divided by x2 minus x1, which is going to be 2 minus 0 divided by 5 minus 2. And that is going to give me a slope of 2/3, positive 2/3, which means now I have y equals 2/3 x plus b. And if I want to find b, which is the y-intercept, then I need to plug in a value for x and y. I will choose the coordinate point 2, 0, because that's the easiest one to choose. So in other words, y is 0, x is 2 plus b. And I'll admit this is a fraction. It's not very friendly, but it's not that bad. 2 times 2 is 4. So 4/3 plus b equals 0. Subtract 4/3 from both sides, and you will get b equals negative 4/3. So then finally, plugging that equation into my top piecewise function, it's going to be y equals mx plus b form, 2/3 x minus 4/3. And there we go, we're halfway done the problem. Honestly, that's the difficult half. The x is less than 2 case is much easier. And here's why. So now we're looking at less than 2, which is the red portion of the graph. Again, it's a linear line. I want y equals mx plus b. And again, I have two coordinate points, 0, 2 and 2, 0. I can find the slope the exact same way using y2 minus y1 over x2 minus x1. Or another way I can do it, just to show you, slope is rise over run. My rise is down 2, or in other words, negative 2. And then the run is 2 to the right, or positive 2. And since slope is rise over run, that means it's going to be m equals rise over run negative 2 divided by 2 is negative 1. So in other words, the slope of the left portion of the graph is negative 1. And by the way, we could have done that for the blue graph too, because it's up 3 over 2, and that would get you 3/2. Now to find the y-intercept of the red function, this is very easy, because the y-intercept, I can see it on the graph. It's this point right here, which is at the value 2. So in other words, y equals mx plus b is going to be m, negative 1x, which technically I don't even need to write the 1. I can just write negative x. And the y-intercept was positive 2, so plus 2. And there we go. There is my piecewise function for this one. Again, you can flip the order of it. You can put negative x plus 2 up top and 2/3 x minus 4/3 on the bottom, and that's fine as long as you match the domains correctly, which is the part after the comma. Okay, so that does it for the first one. Now we're just going to do one more. I encourage you to try this one on your own, but if you can't do it because it's too hard, that's fine. I'll be showing you the solution anyway. Okay, so here's my graph. Now to give you the coordinate points, they are 0, negative 1, 3, negative 1, 5, positive 1, and 7, 0. Now, one piece of advice I have for you, if you want to make your piecewise function, how many parts are there? There are 1, 2, 3, 4 parts. Your piecewise function better have 4 parts. And remember, all these lines are linear. In other words, they're straight, which means they're all going to be in the form y equals mx plus b. Although lines 1 and 4 are horizontal, which is a huge hint if you catch my drift. But go ahead, try this one on your own, and when you think you've got it, unpause the video. Okay, so I'm going to be going in order from left to right. For the first part of my piecewise function, I notice it's a horizontal line. I love horizontal lines because it's the easiest thing in the world. They're always just the y value, which is negative 1 twice, which should be the case. So just negative 1 for the function part, and then the domain, the x values that I'm looking at, are 0 to 3. Here's how I write 0 to 3. 0 less than or equal to x, which is less than or equal to 3. One thing I will say, for a lot of these, it doesn't matter if I put less than or equal to, as long as one of the functions have the equal sign, not both of them, then we're good. And I'll explain what I mean by that for function number 2. So for function number 2, immediately I know it's between 3 and 5, so maybe I even want to start with that. 3 less than x less than or equal to 5. This is what I was saying earlier. I have to write 3 less than x. I cannot write less than or equal to because I already used the equal to in the first one. If you wanted to use less than or equal to here, that's fine, but it would just have to be less than right here. Okay? So now, to determine the function at 2, I need to find the slope and the y-intercept. I'm not going to find the y-intercept very easily because it's not touching the y-axis, but I can find the slope very easily because as we can see, it is up 2 and then over 2. Or if you don't see that as easily as I do, you can just say m equals y2 minus y1 over x2 minus x1, which would look like this. 1 minus negative 1 divided by 5 minus 3. That's going to be 2 divided by 2, which gives me a slope of 1, which I said would happen earlier. And then if I want to find the y-intercept for this, I have to plug it in the formula. Y equals 1x plus b. And then I have to choose values for x and y. I will choose x is 5 and y is 1, this coordinate point. So that means 1 equals 1 times 5, which is just 5, plus b. Subtract 5 from both sides, and we get b equals negative 4. Putting it all together, that's going to be y equals x minus 4, and that is what goes in the second portion of our piecewise function. Now for the third portion, that's this line right here. Again, I need to find the slope. The slope is going down 1 over 2. So I know that slope is going to be negative 1 divided by 2, or in other words, negative 1/2. And then if I want to find the y-intercept, I have to choose a coordinate point. I'm going to choose 7, 0. I think that's the easier one. So 0 equals negative 1/2 times 7 plus b. So negative 1/2 times 7 is negative 7 over 2 plus b. That equals 0. And if I want to solve for b, that means I'm adding 7/2 to both sides like this. So 7/2 equals b. Which means for the third function, it's going to be negative 1/2 x plus 7 over 2. And if I think of the x values here, I see that it's from x equals 5 to x equals 7. So watch how I write this. 5 less than x less than or equal to 7. Again, since I chose to put the equal sign here, that means that I have to write just less than. I cannot write less than or equal to there. And then for the very last one, we're looking at function 4, which is just a horizontal line at 0, which means the function's just going to be 0. And this is for when x is just greater than 7. Because it goes on forever. I don't have any sandwich going on. It's just x is greater than 7. And one more time, since I put the equal sign here, I cannot put it there. But if you had those switched, that's fine. And with that, that concludes my piecewise function. I know it was a doozy, but as you can see, we just follow the same steps every time. We just find the equation of some linear lines and put them all together. And by the way, if it's not a linear line, like let's say hypothetically you have a parabola or something crazy, then to be perfectly honest with you, they're probably not going to ask you that, because just based on a graph, we really can only find the functions for linear lines. So I would not worry about any of the x squared or exponential function scenarios. You're just not going to see those. We're just going to deal with linear lines for these types of problems. And with that, that's going to conclude this video. Thank you all for watching. Have a great rest of your day. And I'll see you in the next video. Take care and bye-bye.